Hello and welcome. I'm Jamie Riedesel, a DevOps engineer from HelloSign. We're a direct competitor of DocuSign, in case you haven't heard of us. And I'm here to talk to you about the observability your monitoring system is already doing. Now, I decided to do this talk on observability because it's a buzzword that's going around a lot of the industry right now, especially in the startup space. And I wanted to help deobfuscate some of this and show you how it relates to monitoring and essentially show you it's not as bad as you think it is because you're already doing a good chunk of it. Before we get into that, we need to talk about what is monitoring, because that's the foundation for all of this stuff. Jerry was just talking about monitoring inside your QA stack, which I didn't know about, and I need to go do that. But before we get going, here is your monitoring stack. This is your monitoring stack. Everyone has this. If your monitoring system is cron jobs that send email, you have this. If your monitoring stack is something that's global spanning and rolls up to dashboards that has to integrate inputs from multiple data centers, it's this. And I'm going to have to go through this pretty quickly, but the various components, like your polling engine, that is the thing that actually gathers the data. It could be like those cron jobs, or it could be like your Nagios daemon polling things, or the thing that agent that sits on your box that actually runs the script from the Nagios agent, or even the SNMP agent on your switches. That's all part of the polling engine. The aggregation engine is the thing that takes the data that's produced by the polling engine and then stores it. And over time, either stores it or throws old data away, or does fold spindles and mutilates it as things go on. And that allows you, the alerting engine and the reporting engines, to be able to do their job. The alerting engine is the thing that ties into this. The reporting engine is the thing that basically fills people's email and creates pretty dashboards for people. So these are all components. And again, if you're talking like cron jobs and email, both of those may just be your inbox. Or it could be fancy dashboards, or it could be PagerDuty. It could be anything. This is a very abstract diagram for a reason. On top of that, you've got your API, which is programmatic interfaces to components of your monitoring system. And it's a very important thing, because that allows you to build feedback loops in your monitoring system. And feedback loops allow you to get fancy with stuff, and it's really good, especially for reducing alarms, but that's a different talk. User interface is the thing that your users interface with it, because if a monitoring system isn't actually being looked at, you have a bad monitoring system. So these are components. Humans, of course, are a key part of this one, and the policy engine along the side is the logic that describes how each layer here behaves. That describes how the alarms behave, how much data you keep. Do you keep like 10-second resolution for like 2 weeks and go down to 1-minute resolution? That's all in the policy engine. But like I said, this is your monitoring stack, and all of what I'm talking about involves this in some way. The thing is, there's different kinds of monitoring out there. And I've given some of these talks before, but this is a slide I've used a lot, because you got 4 major types of monitoring. I'll go into each one of those. But the big one, not big one, but operational monitoring, this is break-fix stuff. You know, this is looking at your infrastructure, Open Operations Manager, Cisco, Dell Open Manage, NetApps, various sorts of infrastructure bits that tell you whether or not your switches, your servers, your hardware is functioning the way it should. It's not necessarily tied to applications, or even UPS systems fall into this too. This is operational monitoring. Next up, we have capacity monitoring, which is typically lower duration. It's very slow. You're mostly worried about how soon are we going to run out of stuff. And it's stuff, Grafana, email reports, a whole bunch of things. You know, and capacity can be budgetary as much as it is anything else. Next up, we have our SLA monitoring. This is what the SRE book talks about building. And one of the key concepts coming out of the SRE book is that most, if not all, of your alarms should be tied to SLAs. And this is what's probably going to be setting your phone off, although sometimes those infrastructure things will set it off as well. Typically, capacity doesn't, unless you've like run out of disk space in something. That's a crisis. But you should have seen that beforehand. But anyway, that's another thing. And this is very much about monitoring whether or not you're meeting your promises. Now, performance monitoring is interesting because it's not like the others in that it's typically done ad hoc. You're trying to answer a specific question. You're trying to do performance, so you're doing some performance loading. You're trying to see how the system behaves. So you stick in some probes a few places. This could be very high granularity. You can even capture every single system call for tools such as strace on Linux, perf, or Linux Performance Monitor on Windows, various sorts of things, Wireshark to catch what's actually happening on the network, or Procmon to see which each Windows system call is happening. These tools are used to figure out as part of debugging, troubleshooting, profiling activities, generally not done continuously, and they're not necessarily persisted for long, because you're looking at them immediately and you may be typing up a report to see how this new idea we have is going to perform. But we do need to want to ask the questions, what does each of these answer? So for operational monitoring, the question is very basic. What is currently broken? What is likely to break soon? It's very simple. And if it's broken, maybe tell me about it. Capacity monitoring is how much do I need and when do I need it? And there's lots of consumables you can be looking at here. You've got disk space, of course, cloud provider budget. Because if you're like an Azure or Amazon and your monthly spend is creeping upwards and you're only allowed $20,000 a month, but your last 3 months are getting closer and closer to that line, that tells you, the manager, that you need to either beg for more budget or push for some downward pressure on your costs in some way. So that's a consumable that you can use in this wonderful new public cloud environment we have. Overtime allowance, for example, if the people in your data center are unionized, you may actually have overtime over there and you may be over budget for that. So maybe crack back on certain of your after hours activities. P1 incident usage. So many vendors regulate the number of P1 incidents that you can get per a contract. And you may only get 10 a year, and if you burn through 7 of them by March, that's a thing you need to be aware of. Smart hands budget, for example, if you're in a shared data center, they may have technicians on staff that can go in and hit a reset button for you. But every time they open that cage and hit the reset button, it's $250. So there may be a budget that you're on or over. So this is all sort of capacity monitoring, goes in many different ways. Service level monitoring is all about promises. Are we meeting our promises? And how close are we to failing to meet our promises? That picture is our CEO and CIO, just in case you know, because they're weird. It's great. But yeah, this is where the SRE book concepts of like service level agreements, service level objectives, and service level indicators come in. Because this is the framework you would use to narrow down your monitoring, your alerting overload, and just the ones you specifically care about. But that's not today's talk. So performance monitoring is all about investigation. There's no pre-built question. You have this capability already there to be able to answer ad hoc questions because you always need to answer weird questions you didn't think of before. Things like, how does this behave? What's so magical about it? 280 milliseconds round trip time, because when queue latency went over that line, bad things happen in ways we didn't expect. So you need to go in and figure out what is happening with this latency thing. And what happens when I change this one backup flag? That could be good or very, very bad depending what happens, but you're going to watch that thing. And, like Wireshark, we're checking some stuff there. But yeah, performance monitoring is all about investigation. That's the thing. Observability is also all about investigation. It's all about questions. Here's a question. What signs do we see before this queue gets saturated? This is a great post-mortem style question. Things went wrong. You're now in the post-mortem process, and you're asking questions, what did we see, when did we see it, and how can we make sure we notice it the next time? And some bright spark goes in and says, okay, your service level indicators show off that you know the queue size, you know the queue latency for when jobs enter the queue and when they leave, but things went wrong in ways that you didn't expect, because when you're doing your system modeling and setting up your alarms, there's some behavior we don't understand here, so you have to go ask. And so someone looks into your system and checks that you are getting worker start, worker stop times and for various things, and you assume worker stop is when they go to a queue and picked up by a different job and moved on. And somebody does some analysis and realizes that for a specific workflow, the worker stop job, which is when it queues, and the worker start job on the other side of the queue is radically different than what your queue latency is when it gets past a certain level of load in the queue. That's interesting. Again, you're probably already tracking these data, it just wasn't correlated before. is the SLA for this microservice set right? Again, another great postmortem style question. Say you have a new microservice that's coming in. It's feeding data into a different microservice that already has two producers going into it. You look at the SLA for that one, you see that there's plenty of life into that one. When this new service starts producing, about 50% of the load you expected it could take, this one fell off the chart. It just stopped working, which is a clear sign that SLA is wrong. But the thing is, before, when you're doing your testing for this microservice with the two producers, you got up to that higher level. What is it about the third that changes it? And as you're looking through this, you notice that similar latencies show up. When this new service started producing, perhaps it's a different library, maybe it's using different TCP flags or something, and you see that, for whatever reason, the jobs are more expensive from this new one, and your assumptions about how this SLA work, this defined is wrong. Again, post-mortem work. Which should show that we're really monitoring is a superset of reporting and alerting, and observability, which I've just talked about, is a superset of monitoring. Because the SRE book is all about building these alarms and only monitoring what you should monitor to make sure you're meeting your promises. But here's the thing. Development needs to know about how to write their own software. It's all about feedback loops. And you already have systems in place. You're monitoring more than you need to, simply because the engineering and support, in some cases, needs to be able to look to see how the system is behaving over the last year or the last month or week or whatever, and see how that's changing, how did this commit change the wiggly lines in Grafana, stuff like that. So it's already there. It just may not be wired into alarms. And you're doing it more for developer support than it is for like your own feeding the pager thing. But we're getting into a different area here, and I do want to talk about a few more questions. Here's a great one. Did we see signs of probing before the March 9 security incident? Security incident? Well, theoretically, that's supposed to be all in the SIEM, which is this monitoring system way over there in security that I, in operations, never touches. So this means we need to talk to security. They may have been talking to us rather pointedly for some time, because security incident, but they're looking for signs of probing. They know when they came in. So we know the entry points. So we, with our systems logging and our application logging, go into the logging system and try to figure out what weird things happen on the entry point that may have been a herald that someone is trying to grind their way in. And you find something in your Apache logs. There's this one API endpoint that was throwing 403 errors for weeks until it finally threw a 200. And after that, everything went to hell. So this is a case of using cross-functional work, non-monitoring stuff, because who cares about 403s? They happen all the dang time. But apparently this one was different. So that's using your logging system to be able to save your bacon. Here's another one. What happened to this one transaction that made it go so horribly wrong, and did anything else fail that way too? This is one that probably comes from your support teams. High-value customer, or maybe a high-level executive says, this thing failed, I need to know why. Support comes to the operations group saying, big money or big reputation is at risk here, I want to answer this question. So you go to your logging system, which is more of a telemetry stream, and you look through the system, you find the one transaction they're talking about, and you say, okay, they had this big pipeline, and it got about there, and it stopped for some reason. And you can tell that because they came to you recently enough, it was still in your system, and you can see that as part of answering the question. Now, this begins to introduce the concept of telemetry systems, and I'm going to break it out from observability systems soon enough. But first I want to talk about what we've been talking, the functional part we've been talking about for a while, and that is centralized logging and metrics, which we've touched on a few things. These are additional systems that don't get talked as much about in the monitoring context, but they're definitely useful for engineering support. Now, centralized logging is kind of what it sounds like. If anything is producing logs, it goes into one spot so you can fold, spindle, mutilate them, and present them however it is you need to do. Metrics has been a big word for the last several years. It's about taking some of your logging and turning them into numbers instead of text. Numbers store easier, you can keep them for longer. Makes pretty charts, and people like charts. They're also useful for making decisions. So observability really is about all of this in here. I want to talk a bit more about centralized logging, because if you're not doing it, you really should. They come in many different types. Now, this is a simple one. everything you have that speaks syslog goes to a lone syslog server that dumps files on an NFS cluster. You then, SSH to the NFS cluster, you then grep through text files looking for what you're looking for. This style of centralized logging has been done in environments for 25 years now, if not longer. It works, it's there, it's functional, it does what it says in the tin, but it's still centralized logging. And you can definitely have things like Apache feed data straight into syslog and go to your centralized syslog server. All those logs are out there on that NFS cluster for you to grep through. But there are often more complex systems. Now this is a somewhat more complex one that uses Logstash, and in this case we have our producing systems out here. They all ship their log lines off to a queue system, which is like Redis or some other AQMP thing, or Kafka. And then in this case we have a Logstash system, a scalable pile of Logstash boxes that just pulls jobs off this queue, does the enrichment it does, and shoves it into some data stores. And here's the thing about this kind of system. When you have this sort of logic in here, you can actually use that as part of your monitoring system as well. Because if you have something up here like a backup script, and the backups fail because you have a verification script, it can emit something into the log stream. It goes through here, and when Logstash sees that backup failure alarm, it can then fire off a call off to PagerDuty to say, backup failure, tech, come and take a look at this one because you're out of your SLA. So Logstash can be a part of your monitoring system as well. It's a usage that I was new to at my current job, but it's been a very powerful thing because you have on scripts out here, you have an automatic way to access curl, frankly. Because if you're in a controlled environment, there's no outside access over here. You can fire off a message to something that does. So that's very powerful for monitoring. And for observability here, these databases are so incredibly useful because these will build your charts. And those are what you're looking for when you're trying to figure out what that one transaction did that got that manager so angry. How long has this been a problem? Because these systems are large. They've got retention periods. I'm going to be talking about how to make those bigger. Now here's a bigger one. So this is a much more complex system. So we have our producers talking to a queue. But at this first level of Logstash, what it's doing is routing. All it is just say, okay, where did you come from? Where do you go? And it fires off to different parsers and different groups. So if you're a very large organization that has multiple business units, such as a finance team or an international growth team, that don't talk to each other, but still have a common shared infrastructure, this is how you can get different groups getting things. So we have this question, how did queue latency change as a function of commit hash? Well, that's product group A asking that. So as part of their deploy queues, they push out a new deploy. All the logs come filtering back into here, into their own system. And so they can see for their own stuff how that changed because they've done the enrichment as part of observability. So now that I've shown that you already have a system for this, because most people do have some form of centralized logging just because it's a very good idea and developers like it. But how do you be intentional about it? Because intentional is what allows you to get longer, because for most part, you've been accidental about it so far, unless your developers have been very angry and been giving you resources. So the manage your attention period, because frankly, your attention period is how far back in time you can look, and longer baselines are always better for statistics. But the best way, frankly, raise it to an actual product. Tyler talked about productizing ops this morning. This is what this is talking about, because if you can raise this functionality as a product to your product teams or your product management or your project management, depending on what style of management you're working under, they can start seeing this as an actual strategic asset rather than sort of a skunkworks project in the basement that happens to cost a lot of money. And you may actually get more resources, because a great way to increase your retention period is to get more money. It's great. And of course, your telemetry observability, because telemetry systems are full resolution. They're going to be the most expensive to do. And observability systems are less granular. We'll be talking about in a moment, but those may be different servers entirely, depending on how you do your work. Next up, get your logging under control, because start thinking about events and how you use them. Because so much of observability is about managing events, and events can be many things. For one framework I do like, especially for like microservices or worker-based flows, is this one. Accepted a job, started working on a job, finished working the job, reported my results. 4 stages, for events that anything in the infrastructure should be able to produce, which means you could standardize the format, which eases parsing later on down the road. And you need to decide if stack dumps, are they events that you need to track, or are they errors that you need to stay off to the side? Because stack dumps contain various information that may or may not contain privileged information, so be intentional about how you treat this. Maybe you record the fact of the error in the observability system, but you keep the full stack dump in the telemetry system. And do you need to track every variable assignment? Because when you start talking events, because frankly, if you give 8 developers a piece of code, you're going to get 8 different grammars for producing print statements. And some people may care about putting that print statement in of, I've built this code. I'm about to test this value to this value. I took this branch. I took this other branch. That sort of in code, in function debug logging that we put in. Do we really need that? And if you're building an observability system, this is the time in which you can look at your logging, go to your developers and say, help me out here. Stop doing this, or at least tag this sort of stuff in a way that I can filter it out. So by getting rid of this, you can increase your retention period because you're reducing how much you're storing, which is very useful. And add context to events, which is incredibly, incredibly important, because this gives you things like if you can add commit hash, this allows you to put this commit produced this event, this hard allocation. Because if you have like a deploy stream in a different channel, so like we deployed this commit hash at this timestamp and deployed a new commit hash at that timestamp, because it's actually on the event, you don't have to do this analysis of trying to create this time box, taking that time box and applying it to your observability system and pulling out those and hoping that they are in fact correlated directly. Whereas if you are putting commit hash on your events, you know for sure that that code produced that thing. And if you had a deploy failure in which only 20% of your services actually got the new code, you can actually see that sort of thing in the events that are produced. If you're using Amazon and you're using AMI as your unit of deploy, so you have your pipeline that produces an AMI at the end, you deploy the AMI, this allows you to track that as part of your logging stream. Your Linux kernel version, this one we all have recent pain for, because when the meltdown stuff came out and suddenly performance changed radically in certain circumstances, you could see that as a sharp line if you're tracking kernel version on that. Data center, perhaps your data centers aren't built the same or have different firmware versions and they perform differently. You can start seeing correlations there. Memory size of your systems, which is useful. And this another one, which is sort of like that worker tracking I just mentioned. But if you're talking a web system where someone uploads a new profile photo, so every event produced by that user for their entire session will get a session ID. That upload profile pipeline will get a workflow ID. Each stage in that pipeline will get a process ID, which means every event will have all 3 tags, which allows you to get very granular about how you're looking at these systems. Very useful for telemetry. It's also useful for the analytics stuff. We need to get in when we're talking a bit later, especially when we're talking about ETL, because this is a technique that your company is already doing for business intelligence. I don't see it happen very often on the IT side, because this is where sort of a form of retrospective analysis of your data sets to create enrichment. And it's very useful for us, because if you're talking a system that doesn't introspect very well, for example, if you have a system that will produce start times and stop times for your workers, but doesn't actually admit, I took this long as part of the event, you can retrospect that and say, okay, this process ID has both start and stop events, and I can create a new event saying this workflow ID started here, stopped here, had these outputs, and worked into this as part of a bulk process that happens later. So, thing is, business analysts, they're already doing the work. You may not be working with relational databases, but they have the statistical knowledge you need to deal with the next problem, which is statistics, because sampling is the way to make observability go really, really fast. Because sampling is lossy, but the thing is, if you can sample 10% of your events, a 30-day retention period turns into a 300-day retention, and that allows you to get much more visibility into the cycles of your system. And you do need to do it right, so it's people who actually know math, but know your event rates, because if you have something that happens a couple hundred times a second, you may only need 1% of those persisted. But if you have a different event that happens a couple times an hour, it may be a couple times an hour, You may need all of those. So be intentional about your sample rates. And this also makes SaaS products more affordable, because things like Honeycomb.io and some of the other products are very clear about how you use them and how you save them, because they tell you outright, sample your stuff. Because every single one of them charges either by the event ingested or by the gigabyte. And if you're trying to send your entire telemetry fire hose at them, you'll be paying Splunk level prices, if not worse. So sampling allows you to do these things and get very long data sets to get you multi-year introspection over time. So, but here's the thing, beware of PII bombs, especially in those stack dumps. But accidentally revealing personally identifiable information is varying levels of liability depending on your industry. And thing is, you may need to be ready to rewrite history, because if in a certain commit, 10% of a certain type of transaction blew stack, and that stack dump includes parameters. And as part of the security team, they look back and see that for 2.5 days, there are 7 people who had patient ID and diagnosis as part of their parameters in this telemetry system that the entire support group can see. That's possibly a HIPAA breach. So be careful about these sorts of things and be ready to rewrite history, because you're not going to be able to save this personally identifiable information that is out of context forever. So if you're working as immutable logs, which that NFS cluster often is, so if you've got that NFS cluster full of terabytes and decades of data, you're going to have to rewrite those files to get rid of this PII, especially in the new privacy regimes that are going on. So be ready to rewrite history if needed, and be proactive to make sure that you're not going to emit those sorts of data into your streams. So next bet is definitely containing costs, because it can get expensive fast. So first off, productize your observability. Get those resources, get the money. That will give you more to work with, allow you to talk to more people, since you have the management buy-in at that point, and since they realize at the product level, hey, this is the thing we do. We like this sort of thing. You talk to each other, and they have that sort of global view and realize that those groups and those groups need to talk, that they don't historically do. Piggyback on existing ETL and business intelligence systems, because they're already doing grinding on relational databases for going into Redshift or other systems. But now they can use it with yours to further enrich your data and find insights that you weren't there, and allows product teams and engineering teams to be able to characterize change of performance over time. Incredibly useful. Take a hard look at your data stores, and is Elasticsearch the right thing for you? Because Elastic is great in a lot of things, but there's only so much it can do. Or maybe you've got MySQL involved because you're doing like Solarwinds or something that dumps all of its analytics to a relational database. Is that the best data store to use? How does it scale? How does it scale up? How does it scale out over time? Or like MongoDB, is it better? Whatever it is you're using for data store, or even RRDB files, round-robin database files, are they best for what you're doing? Take a hard look at the software as a service systems, because they can do so much for you if you feed them right. Because that is a potentially large financial liability if you get the data ingestion side wrong. But they also have the visualization tools built for you, so that you can give the squiggly lines, you can do the analysis, you can do the correlational analysis, especially if you've got the context baked into your events. And take a hard look at separating telemetry from observability systems. They're different missions. This may mean you may need 2 complete different data stores. One to deal with the telemetry style questions coming out of engineering and support, and a different, maybe even different technologies for your observability systems that is there for long baseline analysis that you need to do. So your to-do list coming out of here is to get text-based monitoring in place if you haven't had it already. This is kind of basic stuff, but this is something you definitely need to get in. And if you're still doing syslog and NFS clusters, you may want to consider getting more visible on this, because it's reprocessing that is okay, you can do that, but it's very expensive in a lot of cases. Get context into your events, because that enables the correlational analysis that is the real power of the what happened here and why did I not notice sort of things. It's the thing that tells you that the reason a microservice fails is because 10% of the nodes in that microservice cluster are still in the old commit. Regularize your logging statements where possible to ease machine parsing. I mentioned this before. 8 programmers create 8 different grammars for print statements. And if you can at least regularize those, the machine parsing of that English language stuff makes it a lot easier. And if not, get them into metrics directly. Pitch observability as a product, productize your operations, productize these monitoring and observability systems. And consider ETL-style batch mode analysis to provide further enrichment of this. This is cross-functional, do the DevOps team, talk to the ETL people, and they'll be like, I've never worked with that sort of data before. And once they get the idea of how to get the data out, they know what to do with it once the data's out. And you probably know how to get the data out because you write these systems. And increase your attention periods through sampling, because that is really how you manage to get multi-year details on how your system operates. Because if you're talking machine learning is showing up a lot in some of this stuff because correlations is machine learning. But here's the thing that I am concerned about for any of the machine learning stuff, and I call it the Memorial Day problem. What happens on Memorial Day, that one moving Monday a year in which your production loads are so far below normal? Does it light up your pager at that point? The only way you can detect Memorial Day is if you have multiple years of data in which to analyze this stuff. So long baseline for this sort of thing. So very much what observability is about, because it shows you how the performance of your system has changed over time. It's good for investor calls. It's good for roadmap planning if you're a growing startup and everything else. So that's what we have, and I think I hit time. So I'm a little over. All right, thank you. We have a little bit of time before the next system, so I'm ready. I'm up here to take questions, and thank you very much.